Alright everybody, we're back with another round of equations and annoying mouse clicking. We saved the worst two for last, and I will begin with the pyramid. What makes the pyramid so difficult is the slant calculations, which we'll talk about in a moment. We're going to begin by constructing the pyramid. Now, the pyramid we've been talking about is a rectangular based, don't forget a square is a type of rectangle, so that applies here as well. But from a drawing perspective, we would actually not see the rectangle of the base unless we were looking at it directly from the top or directly from the bottom, in which case we would not see the height or any of the other faces. Therefore, we actually have to draw it more like a parallelogram. So we can go here and grab our parallelogram tool, and begin to draw whatever type of perspective base we would like. Okay? You could change the steepness, and you could change the thickness, make it long like that. However you want to do it is well and good and up to you. So let's go ahead and make ours right here. Let's make ours right there, okay? And I'm going to go ahead and get rid of that gray fill. Now our next step is to draw the height. And that is going from the base all the way up into that peak point where all the faces meet. But to do that and avoid being oblique, we need to find the center of this base. Now, you might think, looking at these guides, see these square guides around the edges, that if I just connect those and connect those like we did with the oval and the circle, that I will have my center. It's not actually true here, okay? Actually, what we're looking for is connecting the diagonals of this parallelogram. So to help my accuracy, I'm going to go ahead and zoom in like so. Let's just zoom in one more time. That might have been too much. Nope, we got it. And I'm actually going to draw the diagonals. Okay. Now, in the long run of this problem, these diagonals serve no purpose other than to find the center. So I really don't need these diagonals when it comes to the final product. There's our center. And we want our height to go straight up from there, be perpendicular to the base. Okay, so we're going to zoom back out. Just zoom out just a little bit, not too far. And then I take my height and I go straight up from there. Now that looks like it's actually not. You go as high or as low as you need. Remember to keep our things proportional. Okay. I'm actually going to zoom in if you don't mind. This is going to bother me if I don't. And take this guy. It wasn't too bad. Still a little off, still bothering me. And it appears it's going right back to where it is before. I'm going to zoom in one more time. Okay. Let's... I'm sorry, for most of you at home right now, you're all going, just get it over. That's pretty good. That's better than it was before. Okay. Alright, so there we have that. Okay, now, as I mentioned before, the diagonals really serve no purpose, so we can go ahead and get rid of those. Really, at this point, all you need to do is connect that tip-top point. I guess I'll zoom back in. Connect this tip-top point to each of the four corners, creating our other faces. Okay. 1, 2. Guess I don't need to count for you. This isn't for, and I'm gonna have to fix that one because it looks terrible. And one more. I am zooming in on that because that just looks like horrendousness. Oh, that's a hot mess. Okay, let's do a little fixing here. That one's especially bad. There we go. Alright. Alright, that's good news. And our pyramid, like a rectangular prism, will have a length, width, and a height. But before we talk about that, there is one other thing that we need to talk about. As I mentioned before, we have different slants involved in this rectangular base pyramid. There are two different slants that we need to address. There's one that comes from the tip top up here, and it goes all the way down to the midpoint of the width. This is the width. I'll label it all in just a few minutes. There's another one that goes from the tip top to the midpoint of the length here. And those should be different if you've got a rectangular base. If you've got a square base, they should be the same. Okay? But again, like the slant we talked about before in the cone, you can't just make up these numbers yourself. You're actually going to have to calculate these two numbers. And it's going to be based off the Pythagorean theorem. So that slant 1 goes from here to the midpoint, and careful not to go there, because that's not going to be the midpoint. So you have to be, it's not cooperating. It's a prime example of why we want to zoom in so we can control it to go where we want it to go. That is clearly not the midpoint. So we will make it go more to the midpoint. I think we're pretty close there for now. I'm going to take it and move on with it if that's cool with you. If it's not cool with you, I'm doing it anyway. And then we go from the top, somewhere down here, the midpoint down there. That one should be easy to find. And there we go. So we've got our height, our slant, and our slant. Okay? Now, it's very important that you stay consistent with what I'm about to give to you, because if you get the two slants mixed up, and I'm just noticing this isn't the midpoint, it's bothering me a little bit, I'm going to leave it alone. If you get the two slants mixed up, you will be plugging them into the equation in the wrong spot. And, of course, if they're in the wrong spot, that means you're doing the wrong calculation. All right? So let's take a look at some measurements here. Let's make up some measurements. Okay, I am going to go ahead and this is the width. Sorry about that. This is the length. Here's our height. Getting a little better at writing on the iPad. And we can make those up how we wish, yeah. So let's say that the height in this scenario, the height looks like it might be the same as the width, maybe a little less. I don't know, it's pretty close there. So if we said the height was, say, 8 yards, I don't know why it doesn't want to write. There we go. And let's say the width is the same. 8 yards. It's beautiful. And the length is definitely longer than those, maybe ever so slightly. Let's go with 9 yards, okay? That's a D. It's a D. Get over it. Oh, I just bothered some of you with that. Now, the slants, unfortunately, as I mentioned before, we are not able to make up. But this is where it gets really, really important, okay? We are going to call the one on the right face Okay, the one that meets the midpoint of the width over here, we are going to call that slant number 1. Okay, it's S sub 1, slant 1. And the one that is here in the front that meets the midpoint of the length, we will call that slant 2. There we go. Slant 2. Now, again, slant 1 is the one that's going to go from the top to the midpoint of the width. Slant 2 goes from the top to the midpoint of the length. That's very important as we establish the equation for surface area. Start with volume. Volume's easy. Very much like the the cone relates to the cylinder. We could take 3 pyramids of the exact same size, same length, width, and height, smush them together, and create a rectangular prism with that exact same length, width, and height. Which means that since it takes 3 of them to smush together, the volume of a rectangular prism, normally being length times width times height, we are going to take a third of that. A third of that. The surface area is a bit more complex. Let's develop this equation for a moment, shall we? Again, the surface area is the area of all the faces added together. Now, the base is a rectangular, just a rectangular base. And we would normally get that by doing base times height, or in this case, length times width. And we still will. Okay? So that length times width gets us the area of just the base. But all the other faces are triangles, right? And that has a different area equation, 1/2 times base times height. Good news is, on the left side, the left face and the right face are congruent triangles to each other. So we have 2 of the same triangle. We have 2 triangles with the same 1/2 times base times height, and the 2 cancels out with the 1/2 to just leave the base times the height. Well, the left face and the right face, the base is the width and the height is that slant 1. So for the area of the left face and the right face added together, all we have to do is the width times slant number 1. And we're going to add that to our previous calculation of the length times the width. Again, we don't need the 1/2 in there because there are 2 of the same, and when I multiply it by 2, 2 and 1/2 make 1. Okay? Likewise, the front face and the back face also have equations of 1/2 times base times height, but since they're congruent triangles, there's 2 of them the same. The 2 will multiply with the 1/2 canceling out, leaving just the base times the height. And in the case of the front and back faces, the base would be the length, and the height would actually be the slant 2. So to find the area of both the front and the back faces at the same time, we just do the length times slant number 2. Okay? And we add that to the other previous calculations. So we've got surface area equals length times width plus width times slant 1 plus length times slant 2. And we still haven't talked about where slant 1 and slant 2 come from. So I'm going to need to do a full erase here of a bunch of stuff to create a lot of space. I previously mentioned that we will be using the Pythagorean theorem, but a lot of people aren't quite too sure exactly what I'm talking about when we're talking about using the Pythagorean theorem. Well, let me highlight something on the screen for you. I'm going to attempt to highlight here, okay? Let's take S1. We'll start with S1. The height from the tip top, I don't know, can you see that? It's there, faintly. And slant 1, if I just connect those across here, I've got myself a right triangle. And in this right triangle, the height is one of the legs, and slant 1 is actually the hypotenuse. Okay? So we're trying to find the hypotenuse of a right triangle in essence. How are we going to do that? Because normally it's what? Leg squared plus leg squared equals the hypotenuse squared. We already know what one of the legs is. It's the height. Just mentioned it. And we already know what the hypotenuse is. It's S1. Okay. So what is this other mysterious leg, the one that I just connected the height to the S1 to? What is that? Well, it just so happens since the height comes directly perpendicular to the base at the center point of the base, it would make logical sense to us that that third side that I made, the second leg, is exactly half of the length. Notice it's parallel to the length there. Okay? So it's going to be half of the length. And this is where it gets a little bit tricky. Half of the length squared. So let me read that to you because it is quite sloppy. And again, I apologize for this. The height squared plus half of the length squared equals slant 1 squared. So I'm actually going to do an example here of what this looks like. I'm going to go through with the specific numbers here because I know some of you might be thinking, what does this look like? Well, we know the height is 8, right? And we know the length is 9. So it's actually half of 9. Now, you don't want to square it first, okay? That half of the length is inside those parentheses. I put those parentheses there for a reason. If I don't put those parentheses there, then I'm squaring the length first before I take the 1/2. But with the parentheses there, as I have it written, you should be taking half of the length first and then squaring it. Okay, and that's going to equal S1 squared. Well, we don't know what S1 is yet. We'll deal with that in just a moment. And besides, I kind of ran out of room. So let me go ahead and simplify this. Normally, I would not recommend not writing the equals S1 squared off to the side. But in this particular case, I'm just running out of room. I'm doing this for space, okay? 8 squared is 64, although I'm going to hold off on that just for a second, actually. I'm going to do the parentheses first. Half of 9 is, of course, 4.5, or 4.5. Now I can do my exponents. 8 squared is 64, and 4.5 squared is 20.25. Okay? Now remember, those are equal to S1 squared. The 2 is called a superscript, and the 1 is called a subscript. I can show you in a moment if you're not sure how to make those. Hopefully you found them by now, but if not, I can show you really quick. 20.25. I add those two numbers together, and I get, of course, 84.25. But remember this, and this is where a lot of students miss out seriously on these points. I very, very, very rarely have a group that gets all the points on the pyramid, and usually it's because of the S1 and the S2. A lot of students leave their answer at this and say 84.25 yards is their S2. But remember this, folks. Look at all the other numbers you chose, 8, 8, and 9. What makes us think that S1 is 84.25? That's way far off from all the rest of them. That doesn't make any sense whatsoever. Okay? It's because that's what S1 is, squared. We get rid of the squared with a square root. So we got to take that 84.25. Go ahead and add 64 to it here. And I've got to square root that. which for me, there it is, I have to hit that button and then do that. Big decimal now, right? 9.18. 9.18 is what I end up getting. So my S1 is approximately 9.18 yards. Okay? And then from there, I can go ahead and plug it into the equation. Of course, what I do with the equation from there, the surface area equation, is going to have error. We know that because you're using a rounded S1. You're not using the exact number in your calculation, but that's okay for the sake of this. Now, I also haven't talked about S2. I'm not going to go through the full example, but I am going to show you really quickly the equation for S2. I bet many of you could probably figure out what it is based on the S1 equation, but it doesn't hurt to go over it real quick. Okay. So here's S1, or S2, excuse me, I apologize, S2. If we're looking at, let me grab the highlighter, I'll do purple this time. If we're looking at the height here, and then S2, this is going to be weird, I know. If I connect those two, it's going to make this, see that there, it's kind of hard to see. It doesn't look like a right triangle because of perspective, but we know in the back of our mind that it is. S2 being the hypotenuse, and H being one of the legs, right? H is a leg, and S2 is the hypotenuse. So what is the other leg, that weird one there that I connected? It is, of course, half of the width. So again, we want to put this in parentheses because we want to take half the width first. And then we square it afterwards. There we go. Okay? And that'll help you calculate your S2, going through very similar steps as we did the S1. All right? Really quickly, I want to show you all, if you're struggling with figuring out how to write a subscript or a superscript, an exponent or subscript is the one that's below. Let me show you how to do that really fast. So let's say we wanted to write S1 squared. Okay, if you were typing that out, the 1 we want to be a subscript, so you go up here to Format Text and make it a subscript, and then you highlight the S2 and go to the same spot to make it a superscript. That's how I would type S1 squared. Okay, those of you who are looking for a square root symbol, you can find the square root symbol where you find the pi symbol up in the special characters, but you would really need to understand parentheses to technically use it correctly in this scenario. Unfortunately, Google Slides does not allow you to type in equations. I'm not exactly sure why they haven't developed that yet, but they won't. I personally, as a tip, don't think you need to show any square root symbols anywhere. I think as long as you're showing your step by step, and I don't think we need to take it that literal to actually show that you did a square root. I mean, when you think about it, you guys aren't actually showing when you subtract something from both sides or add both sides or whatever, right? So I'm totally okay if you do not show the square root of both sides. Obviously, you'll show the step before that in the answer, but not the actual taking of the square root. It is not something that I don't think needs to be seen. And it could actually, if you would try to insert it there and don't do it the right way, it could actually ruin the presentation. So it may not be worth that risk. Okay. All right. I'll be back in a few moments with the the triangular prism.